In this lesson, we'll learn how to solve and graph or compound inequalities. So again, our essential question is, how do you solve more than one inequality? First, let's take a look at what an or inequality looks like on a graph. Remember, or means one or the other. It does not mean both have to be true. So it is different than an and inequality. So we're going to set up 8 and 13 with one value in between as kind of a reference point. F is less than 8, so we have an open circle. 8 is not a solution, and less than shades left. Unlike with and compound inequalities, where you can only shade where they're both true, this one you simply put both inequalities on one graph, so we don't have to use arrows on this one. Or F is greater than 13, so another open circle. 13 is not a solution, and greater than shades to the right. Next, we're going to list 3 solutions that will make this compound inequality true. So anything that's shaded, so we could think about if x is 7, 7 is less than 8 or greater than 13. One of the inequalities is true. Both of them do not need to be true. If x is 20, 20 is less than 8 or greater than 13. This time our second inequality is true, even though the first is not. And any other value you can think of that's not between 8 and 13. For example, -3 is less than 8. Even though it's not greater than 13, it still makes the compound inequality true. So similar to and compound inequalities, we're simply going to solve each inequality separately, and then we'll put it on the number line and graph both at the same time. So our first inequality, we're going to add 5 to both sides. We do not flip the inequality when we add. Dividing both sides by a +7, again, we do not flip the inequality when we divide by a positive. So we have v is greater than or equal to 10. Our second inequality, we're going to start by adding 2 to both sides. Once again, we do not flip the inequality when we add. And notice how we get 0 for a result. -2 plus 2 is 0. 0 is a legitimate solution. So don't be afraid when you get 0. It does not necessarily mean you did anything wrong. Dividing both sides by a negative. This time I will flip the inequality. And we get v is less than or equal to 0. Setting up our number line. We need both solutions on the number line with at least one value as a reference point. V is greater than or equal to 10. So we have a solid circle because 10 is a solution, and greater than shades off to the right. Or v is less than or equal to 0, so we have another solid circle, and less than will shade off to the left. A couple of values that would make this true. Any negative number would make this true because negative numbers are less than or equal to 0. And then 15, 20, 3,768 would make that true because they're greater than or equal to 10. Everybody's favorite, we're going to revisit solving fractions. So first of all, our first inequality, we're going to look for a common denominator. What do 5, 10, and 3 all go into? So our least common denominator is 30. So I'm going to multiply each term by 30. Remember, these bars here mean divide, so we're going to divide first and then multiply by the numerator. 30 divided by 5 is 6. 6 times -x gives us -6x. 30 divided by 10 is 3. 3 times 4 is 12. I multiplied by a positive, so my inequality symbol stays. 30 divided by 3 is 10. 10 times 4 is 40. Subtracting 12 from both sides, we get -6x is greater than 28. Dividing both sides by a -6, we will flip our inequality and simplify our fraction. We get -14/3 when we divide each of those by 2. Our second inequality, 4 and 6 both go into 12. So golden rule, I will multiply everything, including that 1, by 12. Dividing first, 12 divided by 4 is 3, so I get 3x, plus 1 times 12. greater than or equal to, because I multiplied by a positive. 12 divided by 6 is 2, and 2 times 5 gives me 10. Finishing solving by subtracting 12 from both sides, I get 3x is greater than or equal to 2. Dividing both sides by a positive 3, I get x is greater than or equal to 2/3, not flipping that inequality when I divided by a positive. So for this one, both of our fractions have the same denominator, which is helpful, but not necessary in this case, because we know negative 14/3 will be less than positive 2/3. I also know 0 is closer to 2/3 than negative 14/3. I have an open circle at negative 14/3, x is less than, so I'll shade left. And I have a closed circle at 2/3, greater than shades right. For OR inequalities, typically you will have it shaded on the outside. Every once in a while you'll have a unique or a special solution where the shading overlaps, but for OR, typically you'll have it shaded on the outside, and for ANDs, typically you'll have it shaded in between. Again, there are exceptions to the rule, so don't just shade on the outside because it's an OR. Make sure that your graph matches your solution. And finally, we'll take a look at special solutions for OR compound inequalities. Solving our first one by subtracting 7 from both sides, we get 2y is less than 6. Dividing both sides by a positive 2, we have y is less than 3. Solving our second one by adding 2 to both sides, I get negative 3y is less than or equal to 12. Dividing both sides by a negative 3. This time we'll flip the inequality because we divided by a negative. Y is greater than or equal to negative 4. Setting up our number line, we have negative 4 and 3, with 0 slightly closer to 3. Y is less than 3, so I have an open circle shading left. And then we have y is greater than or equal to 4, greater than shades right. Now notice when I shaded to the right, I ended up filling in that open circle because 3 is less than 3 or greater than or equal to negative 4 is true. Remember, for the OR inequalities, only one of them needs to be true to be a solution. So in this case, because my entire number line ended up shaded, my solution is all real numbers. And take a look at your 2U try questions.